All right, in this video we're going to talk about the physical and chemical properties as well as changes that occur. So first of all, before we start, we're going to distinguish between a property and a change. So a property, so like if we think of a property, it's really like a description, right? So like a characteristic or a property is a description. It's usually some type of adjective. Whereas a change, it's kind of something. If something is changing, it's in action. So it's a type of verb. So oftentimes people have trouble figuring out the difference between a physical property versus a physical change. Well, change is in the actual action occurring, whereas the property is more of a description. So what is a physical property? It's a characteristic that can be observed or measured without changing the sample's composition. So it's something that you can look at and you can use it to describe, but it's not changing the sample's composition. So there are two types. There's extensive, which is dependent on the amount of substance present, so it depends on the amount. And then independent, which is intensive. So extensive, notice intensive starts with an I, so it's independent of the amount. So extensive examples are like mass. So we can say, oh, that is 40 grams. That's a physical property, right? Because it's not changing the substance itself, but the mass is dependent on the amount. So like if you add more, the mass will change, right? And so it's dependent, meaning like it changes depending on the amount you have. Other things are like volume. As you add more of something, the volume increases, right? So the property will change. Whereas intensive would be like color. Like, so if water is colorless, right? And even if you add more and more water, it's still going to be colorless. A common example that a lot of people miss is density. Also texture. So density is the amount of particles per place, right? Per volume. And so, for example, if let's say I have 2 dots per box or volume, even if I add another box, now there's 4 dots, but there's 2 boxes, so it's still 2 dots per box, right? So density is kind of like how closely things are spaced, or the amount of particles per volume. It's intensive, and the reason is you can add as much as you want, but the density will still remain the same. Okay? All right, so those are physical properties, and then we have chemical properties. So it's the ability of a substance to combine, to change into another substance. So it's the ability to combine. So like sometimes we would the terms would be like it reacts with, or like, so this would be reactivity. Is an example. Let's think of some other, or we can say, so anytime there's fire or combustion occurring, so we could say if it's like combustible, meaning like it's easy to burn, that is a, so it's not like the combustion or the burning is occurring, but it has the ability, right? And so that's a property of a person, or sorry, of matter. Okay, so those are examples. And when you burn something or you react something, that is a chemical change that occurs. All right, so physical versus chemical changes. So a physical change, so this is something changes, so there's actually action occurring, but it doesn't change the composition. A really common example are what we call phase changes, right? So there's 3 phases that we work in class with: solid, liquid, and gas. And anytime you have, so like, let's take the example of melting. So I just think of melting ice. So when ice melts, that's a change, but it's still water. So in that case, we would consider it a physical change. Ice is water, it's a solid form of water, and then liquid water is water. And it's still the same thing. It's not like you've changed it into a different or new substance. A chemical change, though, occurs when you make a new substance, you form a new substance. And oftentimes, there are 5 signs of chemical change. So here are 5 things. This is not like you can go in and see like, oh, the bonds are breaking and that kind of stuff. So there are some common signs that we see. 1, we might see a color change. 2, you might see a gas formed. 3, a new solid is formed. And we have a special name for this, and this is called precipitation. So this is called precipitation reaction. 4, sometimes an odor is formed. And lastly, sometimes there's a temperature change. So when there's a temperature change, 2 things occur. It could either get hotter or colder. So if it gets hotter, that's called exothermic. And if it gets colder, that's called endothermic. So what are some common chemical changes? Like burning, rusting are common. Anytime you react something with something else, so some type of reaction, any type of reaction is usually a chemical change. Why? Because in a chemical reaction, there's new things forming. Cooking, baking, those are all chemical changes as well. Here are the states of matter. You have solid, liquid, and gas. Solid is your lowest kinetic energy, meaning they're moving the slowest. It has a definite shape and volume, meaning like there's an actual shape and volume. And so what happens is if these are the particles of a solid, they're very ordered and they're just kind of vibrating, but they're staying very ordered. Liquid, though, what happens is the particles are moving past each other. So they're moving, but they're still kind of connected. And then gas is the highest kinetic energy. They're kind of moving around as well. Okay, so these are the 3 states of matter. You can see gas is an indefinite shape, indefinite volume. Liquid is indefinite shape, but has a volume. Like you can measure the volume. And then lastly, in a chemical change, we call it a chemical change occurs during, we can represent this by a chemical equation. And so in a chemical equation or a chemical reaction, the mass can either be created or destroyed. So let's just say, well, in biology, you learn that respiration, right? So if you took glucose plus oxygen, you would form carbon dioxide and water, right? So this is like when you breathe in oxygen and you're working out and you're using up your glucose. These are the things that are formed. So this side is what we call the reactants, and this side is called the products. So if, for example, you had 40 grams on this side, you have to produce 40 grams. So like the mass of the reactants has to equal the mass of the products. All right, you have a quick check tomorrow, and there's some practice.